In this video, I'll be explaining both what IP addressing is and how it works. For two or more computers to be able to communicate through a network, it is necessary for them to be able to identify each other uniquely. Now this is where IP addressing comes in. When a computer is connected to a network, it is automatically assigned an IP address. This address allows computers to send their data packets to a specific computer on the network during communication. An IP address is a string of 32 bits. These 32 bits are then split up into 4 equal parts, each containing 8 bits. These 4 binary numbers are then converted into decimal numbers to give you your IP address. The way in which IP addresses are allocated is very similar to the way in which a phone number is allocated, in the sense that a phone number can be split up into both an area code and an ID code. Similarly, an IP address is split up into a network code and a host ID. In this example, the first 3 decimal numbers are used to identify the network. This, however, is not always the case. This is because the part which defines the network code in an IP address depends on its class. There are 5 different class types of IP address: A, B, C, D, and E. Each of these classes has a specific function. A through C are used for allocating IP addresses. D is used for multicasting, and E is reserved for experimental use. Now the difference between all these classes is the way in which they are split between network and host. In a Class A IP address, only the first part of the address is used as a network ID. Also, the leading bit in a Class A IP address is always a 0. This means that the remaining 7 bits in the first part can be used to create network IDs. This means that there are a possible 2 to the 7 network IDs that can be created. The remaining 24 bits of the IP address can be used to create host IDs. This means, using Class A IP addresses, you could have a possible 128 networks, each containing a possible 2 to the 24 hosts. A Class B IP address uses the first 2 parts of the address to create the network code. For a Class B address, the leading bits are now a 1 and a 0. This means that the remaining 14 bits can now be used to create the network ID, causing the amount of possible networks to rise up to 2 to the 14. This time, the remaining 16 bits are used to create the host IDs, meaning a possible 2 to the 16 hosts per network. As the trend would suggest, a Class C IP address uses the first 3 parts of the address to create the network ID. This time, the leading bits are 110, leaving 21 bits to create the network IDs. This means the amount of possible networks has increased up to 2 to the 21. This leaves 8 bits to create the host IDs. This means that on a Class C IP address there are possible 2 to the 21 networks, each containing a possible 256 users. Another important part of IP addressing is a subnet mask. A subnet mask is used to distinguish between network ID and host ID when looking at an IP address. The subnet mask of a Class A IP address is 255.0.0.0. For a Class B IP address, it is 255.255.0.0, and for Class C, it is 255.255.255.0. The portion of the subnet mask that contains all ones marks the part of the IP address that is used as a network ID. The final part of IP addressing is special IP addresses. The 3 special IP addresses are the loopback address, the network address, and the broadcast address. The loopback address is an address of 127.0.0.0, and any data packets sent to this address will be looped directly back to the sender. A network address is an IP address in which all the host IDs have been set to 0. Here are some examples of a Class A, Class B, and Class C network address. A broadcast address is an IP address in which all the host IDs have been set to 255. Any data sent to this address will be redistributed to all hosts connected to the network. Here is an example of a Class A, Class B, and Class C broadcast address. As you may have noticed earlier, using a network address and broadcast address means that the amount of available host IDs on a network is always decreased by 2. This means that the amount of available host IDs while using Class A, B, and C IP addresses are actually as follows. Thank you for watching.